Well, welcome to Lesson 11 on understanding polynomials. Here is your warm-up activity. Go ahead and work on these, and I will give you the answers in class. Actually, there's one problem I do want to kind of set up with you on this slide here. When you get to this number 4, I'm not sure if you remember how to do this. This says find f of g of x. So what you're going to do is you're going to put the function g into function f. So what that means is take 2x plus 7 and substitute it in for x right there in the function f. So you'll have, instead of x, you'll have 2x plus 7 and then minus 5, and just evaluate that. So I just wanted to make sure that you understood what to do and what it means to have f of g of x. So that's all I'm going to say about that. Our vocabulary for this lesson, a couple of terms that we need to make sure that we understand together. And the first one is a monomial. And a monomial simply represents a number or a variable or the product of both of those things where you have whole number exponents. A polynomial is either a monomial or a sum or a difference of monomials. And these will make sense when we go through some examples. Monomials and polynomials both have degrees, and the degree of a monomial, what you do is you add up the exponents on the variable factors, and that gives you the degree of the monomial. The degree of a polynomial is just the degree of the highest monomial. So let's take a look at some examples. Let's work through some of these. So here we have two different expressions, algebraic expressions, and we want to figure out what the name of it is, the degree, and the leading coefficient. Well, this is a monomial. It's only a single term. There's nothing added or subtracted, so that's a monomial. Its degree is equal to the sum of the exponents on the variables. So a has an exponent of 1, even though it's not written, it's implied that it's 1. B has a degree of 3, so we add those together, and so the monomial has degree 4. The leading coefficient is the number or the coefficient that's in front of the monomial. So our leading coefficient here is 5. Now over on the right-hand side, for this example, this has 3 terms. Okay, so this one is not a monomial, it is a polynomial. And its degree is the highest degree monomial. So this monomial right here, this term has degree 4, this term has degree 4, but the last term has degree 5. So whatever has the highest degree, that is the degree of the polynomial. So this has degree 5. So then this would be our leading term. It has the highest power. So its coefficient is 1. So the leading coefficient is 1. That's just the number that's in front of the term with the highest degree. So that's kind of how we label these. So our next problem here says write the polynomial 5 minus 2y plus 2y cubed minus 5 plus 4y cubed. Write it in standard form, then identify the leading coefficient and the constant term. Well, standard form, we need to combine our like terms. We have a 2y cubed and a 4y cubed. That'll give us a 6y cubed. And then our plus 5 and minus 5 cancel out, and then we have a minus 2y. So we ended up only having 2 terms. So our leading coefficient is the number in front of the term with the highest degree. Well, y cubed has the highest degree, so the leading coefficient is 6. Our constant term is gone. There isn't a constant term, so we could say that it is 0 or there's none. Some terms to remember. Okay, we're going to go through a whole table here for you. A polynomial, here's an example of one. Remember, polynomials can have one term or many terms. In this case, we just have one term. The degree, when we just have a single number, whether it's positive or negative, that has degree 0. We classify it by that degree as a constant. That's called a constant. All monomials of degree 0 are constants. This one has a single term. So the classification by the number of terms is that it is a monomial. So we have 2 classifications. We classify by the degree and we classify by the number of terms it has. So let's take a look at another one. X plus 2, there are two terms in this one, so we have two terms. The degree on the exponent on the variable is 1. So this is called a linear polynomial. It graphs as a line. The classification by the number of terms, there are two terms, so we call it a binomial. All right, let's take a look at another one. This one has 3 terms. Its degree, the highest exponent, is 2. That's called a quadratic equation or quadratic expression. The number of terms is 3, so we call it a trinomial. Here's one that just has 1 term again. The degree is 3, so we call it a cubic equation. And this is called, by the number of terms, there's only 1 term, so this one's a monomial again. And the next example, the degree is 4. Highest exponent is 4. The classification by the degree, then, we call it a quartic. This one has 3 terms, so it is a trinomial. So we would call this a quartic trinomial. This one's a cubic monomial. So we use both names. All right, and this looks like the last one, so I can get rid of my screen shade here. This last one has a degree of 5. So we call it a quintic when we classify by degree. The number of terms is 2, so it's a quintic binomial. So let's take a look at what we know and what we've learned so far. This says to classify each polynomial by the degree and the number of terms. So here's an example. There's nothing to simplify. None of these terms combine. It's in standard form, so the highest degree is 3. So the degree of the polynomial is 3. There are also 3 terms. One term is x cubed, one term is 4x squared, and one term is the constant term of -3. So there are 3 terms. So to classify this, it has a 3rd degree, so we call it a cubic trinomial. Okay, so you should have 2 names there. Here's another example for us. And this one says m to the 4th plus 0.5m plus 3m to the 4th. Well, this one, we can combine some terms here, and we would get 4m to the 4th plus 0.5m. So we need to make sure that we're simplifying first, and that's what's in the bubble here. Be sure it's in simplest form before you start labeling it. So the highest degree then on this polynomial is 4. It's the highest exponent. The number of terms turns out to be 2. So to classify this thing, we would call it a quartic binomial. 2 terms, and it's degree 4. And then our third example here on this slide, again, we have to combine our like terms. So we end up with 10x cubed, and then plus a 3x squared and 1x squared is plus 4x squared. Our x's drop, and then we have plus 9. So it looks like we had 4 terms. We have a cubic term, we have a quadratic term. Actually, I think there's a mistake there. Let me write this out before I get running through here. So we have 10x cubed plus 4x squared, and let me just cross these out as I deal with them. I've dealt with that one, and that one, right? And then we have a plus x and a minus x, right? So that drops out, and then we have a plus 9. So we can see that the number of terms should be 3, right? There are 3 terms. The degree of this thing is also 3. The highest degree is 3. So our classification here, and I think I'm going to have an error here, we should have a cubic trinomial. And, yep, so it should be a cubic trinomial. So let's go ahead and cross off polynomial. It is a polynomial. That would not be incorrect, but trinomial is more specific for us. Anything after 3 terms we just call polynomial. But since this one just has 3 terms, we're going to call it a trinomial. So here's one we're going to be subtracting. 4m squared minus 3m plus 2. Subtract m cubed minus 2m plus 5. So I went ahead and rewrote this. The first one I just rewrote as it was. And then I distributed this negative through the parentheses. And instead of subtracting now, I'm going to go ahead and just add these 2 terms together. So it's a minus m cubed, a plus 2m, and a minus 5. That's why I've changed the signs. So basically I'm doing adding the opposite, right? So here we go. If I take minus m cubed, it doesn't have anything to combine with. So I get a minus 1m cubed plus 4m squared minus m and minus 3. So that's what I get when I subtract. Problem number 5 says the profits of two manufacturing plants are modeled by these two polynomial equations. Write a polynomial expression that represents the difference of the two profits. Well, the first one is here, and then I did the same thing. I'm adding the opposite. I am subtracting. So I did that by changing all of the signs of the second one. You'll notice the signs are exactly the opposite as what they are up here. So then I add them together, and I end up with minus 0.01x squared plus 4x and plus 200. And that's it for this video. We will see you in class.